Alright, let's look at resistor in detail. So what does resistance do? What does resistor do? Resistor provides resistance to the flow of charged particles. So normally resistor, a conductor, will have say free electrons in it, right? So similarly resistor will also have free electrons passing through it, and because there will be many more obstacles in the whole resistor, the free electrons will not be able to go very smoothly through the resistor, right? So because it will keep hitting other things on the way. So imagine if there is a resistor which has a smaller area of cross section. So the free electrons are flowing like this, and this has a smaller area of cross section, and the other one has a bigger area of cross section, and the electrons are flowing through it. In which case it will be easier to flow. So in this bigger one, it will be easier to flow. Why? Because it will not hit so much. But in the smaller one, the chances of hitting each other is much more, right? Think of it as a road. If the road is very wide, the cars can pass through easily. If the road is very, very narrow, it becomes very difficult for the cars to pass through, right? Similarly, in this case, if the area of cross section is less, the resistance will be more. And if the area is larger, the resistance will be less, right? So resistance depends on area of cross section, and if area is less, resistance is more. And if area is large, area of cross section is large, then the resistance is less, which means it's inversely proportional to area of cross section. And what about the length? Okay, so think of it as a road. Again, if there's a road which is very narrow, so the longer the road is, the more resistance you will find, right, to go through it, through that particular road. Similarly, in this case, in case of resistor, if the length is more, it will face more and more resistance. If the length is less, there will be lesser resistance. So again, resistance is directly proportional to length, because if length increases, then resistance increases. If length reduces, then resistance reduces. So basically what we can say is resistance is directly proportional to length of the resistor, and it is inversely proportional to area of the resistor, or R is proportional to L upon A, right? And to remove the proportionality sign, we'll put a constant, and let's call this constant resistivity. What is resistivity? We'll come to that in the next flip. So the final formula becomes R equals to rho L upon A.